For threats, the first construct that BREL advocates is a mutual exclusion. And that's a binary operation. A resource is either free or you can access it, or it's locked and busy and you have to wait. Once the resource becomes free, you get a chance to try to access the resource. However, what if the processing that you wish to perform needs to occur only under certain circumstances, under certain conditions? For instance, what if we have a number of threads that are inserting data to a list? These are producers of list items. And then we have one special consumer thread that has to print out and then clear the contents of this list once it reaches a limit, once, for instance, it is full. We'd like to make sure that this consumer thread only really gets to execute its operation under these certain conditions when the list is actually full. Let's look at this producer-consumer pseudocode example. In the main code, we create several producer threads and then one consumer thread. All of the producer threads will perform the safe insert operation, and the consumer thread will perform an operation print and clear the list. And this operation, as we said, needs to happen once the list is full only. For producers, the safe insert operation is slightly modified from what we saw before. Here we don't specify the argument to safe insert when the producer thread is created. Instead, every single one of the threads needs to insert an element that has a value of the thread identifier. For the consumer thread here, it continuously waits on the lock, and when the mutex is free, it goes and checks if the list is full. If so, it prints and clears up the element of the list. Otherwise, it immediately releases the lock and then tries to reacquire it again. Operating this way is clearly wasteful, and it would be much more efficient if we could just tell the consumer when the list is actually full so that it can, at that point, go ahead and process the list.